It too saw its magazines explode, ripping the ship apart.
In the form of about 8 tons of metal coming my way.
Under the seas off northern Europe, a lost graveyard of mega warships.
How had the mighty ship proved so vulnerable? Only Ted Briggs and 2 other men escaped.
Tully, come up, come up. We're landing on something. Go up, go up, go up, go up.
The light from a deep-sea submersible sweeps through the rusted steel, revealing a space that was once the command center of the most infamous battleship of World War II. Inside, a newly recorded detail has attracted special attention from researchers, not because of its size or danger, but because its nature is so unusual that it doesn't fit any recorded data. Let's go through each layer of information to see why this discovery is changing the way we view wrecks at the bottom of the Atlantic. Bismarck was launched in Hamburg in 1939, representing Nazi Germany's greatest military-industrial effort at sea. She was intended to be a formidable battleship capable of exerting strategic pressure on British shipping lanes as World War II unfolded. The design of Bismarck reflected the ambition to control the seas by force. The length of more than 250 meters displacement of 50,000 tons and multi-layer armor system provided significant resistance to enemy fire. This structure allowed the ship to maintain combat performance even under conditions of close quarters and continuous bombardment. The main artillery system consisted of 8 38 cm guns placed in 4 independent rotating turrets, creating a long-range suppression advantage. This was the most powerful gun in Europe at that time, capable of penetrating the thick armor of most enemy battleships. This firepower made Bismarck a significant threat to the British Navy. Bismarck's control room, located deep under 320 mm of armor, acted as the command center for all combat operations. It integrated the FUMO-23 radar electronic sighting system and tactical navigation equipment, allowing the commanding officer to make decisions in low visibility conditions or when the battlefield was rapidly evolving. During the Rhine campaign in May 1941, Bismarck and the cruiser Prinz Eugen entered the Atlantic to disrupt Britain's strategic shipping lanes. The appearance of Bismarck immediately triggered a strong response from the Royal Navy, opening a confrontation that had a great impact on the situation of the war at sea. The Battle of Denmark Strait on May 24, 1941 marked the moment when Bismarck became world famous. Within minutes of the engagement, Bismarck hit the ammunition depot of HMS Hood, resulting in a massive explosion that broke the British ship into pieces and sank, killing more than 1,400 sailors. The destruction of Hood sparked an unprecedented British pursuit. Every available battleship, aircraft carrier, and destroyer was mobilized to track Bismarck. The German ship's power made the British determined to stop the threat at all costs. Bismarck's fire control system showed a level of engineering beyond its time, with the ability to predict ballistic trajectories and correct errors based on sensor data. This provided high accuracy in long-range attacks, giving a great advantage in the first engagements of the campaign. The crew of more than 2,200 men is rigorously trained, with the majority aged between 18 and 25. Their discipline and high performance keep the ship running at its optimum level. Figures such as Commander Ernst Lindemann and First Lieutenant Hans Uhls are at the heart of combat operations. Bismarck also had a strong symbolic value in German propaganda, being hailed by the German media as a testament to the rise of national industrial power. Images of her launching ceremony and sea trials appeared heavily in documentaries, demonstrating pride in military achievement. In terms of overall structure, Bismarck is compared to Titanic due to its enormous size, but its function is completely different. Where Titanic was designed to transport passengers, Bismarck was optimized for a combat role, focusing on firepower, armor protection, and strategic command capabilities. In the video, the Bismarck's launch is simulated using CGI, with angles emphasizing its armor turrets and the scale of its hull. The reconstruction is intended to show how the ship became a strategic variable capable of turning the tide of the North Atlantic. From an engineering perspective, the layout of the ship's space shows a preference for fire control, and key areas such as the engine room, radar center, and control room. This reflects the intention to create a centralized command system strong enough to maintain continuous firepower. From that foundation of power, Bismarck's journey entered a phase of direct confrontation where every technical design was forced to prove its worth in actual combat. The final battle, the Battle of Denmark Strait, on 24 May 1941 became the turning point in the confrontation between Bismarck and the British Navy. As the two sides closed to fighting distance, Bismarck's firepower quickly gained the upper hand. A 38 cm shell penetrated the hood's hold, triggering an explosive chain reaction that shattered the British ship almost instantly. The sudden loss of Hood created a major shock. The British command responded by mobilizing all available battleships, cruisers, and aircraft carriers. The destruction of their flagship pushed them to pursue Bismarck with maximum force and urgency, aiming to eliminate the threat before it could reach safety. For the next 3 days, the British fleet tracked Bismarck across the Atlantic under shifting weather and rough seas. Both sides made constant tactical adjustments. Bismarck attempted to break away and move toward the French coast, where Luftwaffe support would become possible. The situation changed when the aircraft carrier Ark Royal launched Swordfish torpedo planes. A torpedo struck Bismarck's rudder, locking it and removing all steering capability. The ship began turning in wide, uncontrollable circles, exposing its position and allowing British battleships to converge. With the steering system disabled, Bismarck lost maneuverability. Repair teams attempted to free the jammed rudder but could not overcome the structural damage. Escape options collapsed, allowing the British fleet to approach for a final engagement. On the morning of 27 May 1941, HMS Rodney and King George V opened fire at a closer range than in earlier confrontations. More than 2,800 shells were fired. Many pierced the armor-destroyed gun turrets and shut down key elements of the combat control systems. The command area took major hits. The control room suffered structural collapse, communications failed, and coordination between compartments broke down. Deputy Brigadier General Hans Uhls and many senior officers were killed at their posts during these impacts. The crew struggled in worsening chaos. Fires spread across the superstructure, and seawater entered multiple compartments. The combination of internal flooding and external damage reduced the ship's ability to return fire or maintain stability. Bismarck attempted to keep a limited number of turrets operational, but accuracy dropped sharply once the electronic aiming systems failed. The ship listed to one side after multiple hits, making coordinated firing nearly impossible. Flooding accelerated in the engineering sections. Crew members shifted toward higher decks in search of safer positions. Some teams activated scuttling charges to speed the sinking process and prevent capture. Explosions, smoke, and debris continued as the British fleet maintained pressure. The final British salvos destroyed more of the upper structure and forced water into major compartments. Bismarck's hull became heavier, leaning further to starboard. Surviving officers tried to assist wounded sailors, though many internal passages were already blocked. Bismarck eventually slipped beneath the surface and descended to a depth of nearly 4,800 meters. The rapid pace of the battle and the scale of the destruction left a strong historical imprint. The ship had sailed for less than a year before meeting its fate. Out of more than 2,200 crew members, only 110 survived. Many perished from cold waters, exhaustion, or being trapped in flooded interiors. Survivor accounts described continuous explosions and intense vibrations as shells struck the hull. These descriptions matched the wreck's structural damage when documented decades later. The coordinates 48 degrees and 27 and 16 degrees north 12 above became a long-term survey site for expedition teams. Extreme depth and pressure limited direct access for many years. With advancements in deep-sea technology, researchers later obtained complete visual records of the ship. From the remnants of that battle, decades of expeditions pieced together the true condition of Bismarck, resting on the ocean floor. Initial discovery. In 1989, an expedition led by Robert Ballard first approached the Bismarck wreck at a depth of nearly 4,800 meters. Images obtained showed that large sections of the structure were still intact, providing a basis for assessing the extent of damage after the 1941 battle. The submersible, equipped with a high-pressure camera, recorded the bow of the ship plunging deep into the seabed mud. The characteristic angle of the bow suggests a strong impact force when the hull hit the bottom. This is consistent with the rapid sinking speed recorded in historical analysis. The team used ROVs to access hard-to-see spots, including areas where thick armor had been stripped away. The bent metal layers showed repeated impacts from large-caliber shells, confirming eyewitness accounts of the extent of the attack in the final minutes. In the 1990s and 2000s, subsequent missions expanded the scope of the study with newer equipment. The ROV Jason Jr. captured more detailed images of the gun turret rudder and damaged compartments. The high resolution facilitated impact trace analysis. James Cameron took part in several dives in the early 2000s, bringing along a 3D camera system to collect data for digital simulations. These footage showed uneven corrosion along the hull, affected by currents and bacteria on the metal. The biocorrosion mechanism was recorded with high density around the thin steel areas. In contrast, the thick armor plates remained relatively stable in shape. This helped to identify the areas with less deformation, serving as a basis for studying the original interior structure. During the survey, the expedition team discovered numerous personal items scattered around the hull. Clocks stopped at the time of the battle unit insignia, and mechanics equipment were found near the deck. These items reflected the chaotic state of the ship as it spun out of control. Human bone fragments were also found in the sediment, appearing as remnants of the dead sailors, but not intact over time. The survey teams kept the site as is in accordance with the International War Cemetery Preservation Regulations issued in 2006. The technical conditions at depths of nearly 5,000 meters pose great difficulties. Pressure exceeds the tolerance of most conventional equipment, forcing the expedition team to use special materials and control systems. ROV batteries limit the time each area can be surveyed. Visibility is limited to just a few meters, making navigation within the wreck difficult. Narrow gaps and collapsed structures pose a risk of entrapment, requiring the operator to constantly adjust the camera angle and speed of the vehicle. Advances in multi-beam sonar have allowed for precise mapping of the wreckage around the hull. This has allowed experts to determine the path of many of the gun turrets and superstructure fragments, providing a clearer view of the structural breakdown process as the Bismarck sank. In the 2010s, artificial intelligence systems were used to analyze large volumes of dive photos. AI recognized cracks, metal slides, and deformation levels, thereby supporting the construction of 3D models for tactical research. Some findings support the self-sink hypothesis, including detonation points originating inside the hull. This topic has generated substantial debate among experts, and new images provide clearer evidence of a combination of external impact and internal detonation patterns. The improved visibility helps refine earlier assessments of structural failure. Footage from multiple expeditions has become source material for films and documentaries. Images of twisted steel under deep-sea pressure are frequently used to illustrate the destructive scale of naval warfare. Robert Ballard described Bismarck as a victim of historical circumstances, a statement that remains widely cited in later analyses. Less eroded sections allow closer inspection of interior components. Several panels still retain their original arrangement, although the lettering is no longer readable. These preserved areas make it possible to reconstruct the control room layout with greater accuracy than in early surveys. Investigators noted concentrated damage points around the control room that align with the intensity of fire used to disable command functions. Detailed scanning of this area opens a path for future searches for unusual or unidentified objects that may have remained unnoticed during previous missions. Laser-based measurements helped determine the degree of hull tilt and provided data for simulating the forces generated when the ship struck the seabed. This information explains the distribution of sediment in open compartments and supports structural modeling. Magnetic scans detected armor deformations created by extreme heat. Data patterns revealed specific areas affected by high-temperature impacts. Combined with long-term survey results, these signals turned the control room into a central research target, especially after traces appeared that did not match any established damage model. Mysterious discovery. The October 15, 2025 dive was conducted using a new generation of submersibles designed based on commercial deep-diving models. The Smithsonian survey team used an ROV equipped with a high-pressure camera, spectral sensors, and an independent navigation system to reach the central area of the wreck. When light hit the upper hull, the corroded steel reflected weakly, revealing a structure heavily deformed by fire. Armor panels were bent, creating gaps that opened into previously nearly inaccessible compartments. The control room became a focal point when cameras captured cracks stretching from ceiling to floor, a type of cracking not seen in images from decades ago, suggesting the structure continues to change under deep-sea pressure. Inside the FUMO-23 radar and fire control panel were reduced to a crumpled metal frame. Many of the electronic components were separated and buried in a fine layer of mud, reflecting the extent of the damage when the ship sank. The ROV moved slowly over the broken steel to reduce the risk of collision. The camera picked up broken fuel panels and scorched cables in the pitch-black water, which limited visibility. Scanning the steel deck, a strong reflective spot appeared in the sediment. This signal did not match the material in the area, prompting the survey team to adjust the camera angle. A stream of compressed air was used to blow away the sludge, revealing a smooth cylindrical metal object about 30 cm long, with no signs of corrosion. This was unusual as other metals around the control room were visibly corroded. On the surface of the object, there are strange characters in a slight spiral which do not match any German or English alphabet of the period 1940-1941. Under UV light, the object reflects a pale blue light revealing the special material. A higher reflectivity than regular steel is clearly noted. When the camera zooms in, the surface reveals a crystalline structure running along both sides which has remained intact after 84 years at deep-sea pressure. This is a condition that does not correspond to the conditions of the ocean floor. Magnetic field sensors recorded a slight disturbance around the object occurring periodically. This result was inconsistent with the natural background noise of the seabed. Analysis of water samples around the object showed radiation levels lower than the natural background radiation, an abnormal reading that was not associated with the material of the ship. Below the object was a section of exposed cable suggesting that the object had once been part of an electronic system line. This location did not match Nazi electrical designs. During filming, the ROV discovered that the object was attached to a small armor plate by two metal pins. The pin construction and alloy were not up to 1940s engineering standards. When the camera was rotated, the survey team saw that the object was not separate, but showed signs of having been fixed to the control system. This raised questions about a technical function not recorded in historical documents. Some observations show that the seams between the object and the hull do not match Nazi welding or riveting methods, reinforcing the idea that it is not original equipment. Wide-angle shots revealed that the debris around the object did not break off in a direction consistent with a shelling impact. The object bore no scratches, no dents, and no rust. This state of perfect preservation is rare for an ancient wreck. The surrounding corroded steel surface contrasted sharply with the object's gloss, prompting the survey team to focus on analyzing its composition using on-site measuring equipment. The metallic pigments react differently to changing frequencies of light, suggesting a multi-layer structure, a property not found in any other military alloy of the war period. Subsequent sonar readings revealed that the object had a denser core than the crust. Two distinct echoes indicated a complex structure, not a typical hollow one. Thermography showed that the surface of the object absorbed and released heat with a short delay in stark contrast to steel. This suggests that the outer layer has a small ability to regulate temperature according to the environment. The data compiled confirmed that the object did not correspond to any Nazi military equipment. The level of preservation after 8 decades in high pressure increased the attention of the expert team. At the bottom of the Atlantic, the wreck of the Bismarck was once considered a closed story, but the newly discovered object in the control room opens a completely different perspective, shaking up data that has been considered certain for decades. Each detail recovered from the 2025 dive not only adds to historical knowledge, but also raises the possibility of layers of information that have never been deciphered. To stay tuned for in-depth analysis and expanding discoveries, subscribe to the channel now so you don't miss any updates.